All right, let's go ahead and do some practice problems with density. In these problems, we're going to figure out how to calculate density and maybe how to even see how we can use density to determine if something's going to float or not. Now, if you remember from the notes that density is equal to the mass divided by the volume. And so this is the equation that we're going to use for all of these problems. Now, in this particular problem, the first one is asking for the density, and it's giving us this, which is a volume, and then it's giving us this, which is a mass. And so we're given mass, we're given volume, and all we have to do is plug it into the density equation to get the correct answer. So density is going to be equal to the mass, which is 869 grams, divided by the volume, which is 287 centimeters cubed. Now I'm going to pause there for a moment and talk about how we know that the 869 is a mass and the 287 is a volume. Well, there's really two ways. First off, the problem says that it's a mass. So the 869 says it has a mass of. The second way, and probably the more important way to note, is that it has the unit grams, and grams is the unit of mass. Now for volume, it says that it occupies that many centimeters cubed. And so that word occupy kind of suggests that it's going to be a volume. And then the other thing too is that it's centimeters cubed, which is a volume. Now all we need to do is take our handy dandy calculator, plug it in, and then we are going to get the fantastic answer that we want. We end up with 3.027. So this equals 3.027, and I'm just going to go ahead and write it out, 8, 7, so on. However, whenever we're doing any calculations, we need to consider significant figures. And when multiplying or dividing, what we care about is the number of significant figures that a number has. This right here has 3 significant figures. This right here has 3 significant figures. And so because they both have 3 significant figures, the answer needs to have 3 significant figures. If for some reason one of them only had 2, then the answer could only have 2. So it's whichever one has the fewest number of significant figures. So how do we make this 3 significant figures? Well, we get rid of this last part here, but what does this 7 do to the 2? The 7 makes the 2 round up, and we're left with 3.03. And that's the correct number to record using significant figures. But what else is wrong with it? It doesn't have units. And the units for density are either going to be grams per milliliter or grams per centimeter cubed. Now they happen to be the same exact unit because a centimeter cubed is a milliliter, but let's just be consistent with what the problem gave us, and if you take a look, that's our units right there, gram over centimeter cubed. Alright, so let's go ahead and look at this next one here. This next one gives us a piece of wood that has a certain length, a certain width, and a certain height. And then it also gives us the mass. And it's asking what is the density of the wood. Well, if we have a length, a width, and a height, what can we do with that? Well, we can multiply them all together to figure out the volume. And so if we take our 3.0, we multiply it by 6.0, and then we multiply it by 4.0, we'll end up with, I believe that's 72, but make sure. Yeah, 72. Now, again, whenever we're doing any sort of multiplying or dividing, we need to take into consideration significant figures. This has 2 sig figs, this has 2 sig figs, this has 2 sig figs, so the answer should have 2 sig figs. And we also need to write centimeters cubed. Now this isn't our answer, this is just the volume of the wood. We can now use the volume And then we can use the mass to determine the density, because we know density is equal to the mass divided by the volume. And so we have 80.0 grams divided by 72 centimeters cubed. And when you type that into your calculator, you end up with 1.11111, and so on. Now again, whenever we do any sort of calculation, we've got to consider significant figures. This 80.0 has 3 significant figures, because both of those zeros are to the right of the 8, and they are significant because there's a decimal. The bottom number has 2 significant figures, so we're taking 3 significant figures, dividing it by 2, so it means the answer can only have 2 significant figures. It's limited to 2, and so we end up with 1.1, and the 1 doesn't round up, so we get to keep that 1. And then we put our units, and then we get to box it and put a little smiley face. This guy is winking at you. He's got a little nose here. Maybe someone poked him in the eye, I don't know. Oh, we forgot to box this one also. And he's, just kind of happy sitting there. All right, now the question for number 3 says, would the piece of wood float? So would this piece of wood, described in number 2, float in water? Now the density of water is 1 gram per centimeter cubed. And if the density is less than the density of water, it will float. And in fact, I'm going to broaden that definition. If the density of an object is less than the density of the fluid that it's in, it will float. This situation, it's not less, it's actually more. So because it's more, it will sink. So I'm going to go ahead and write this here. And that's the explanation there. The wood would sink because it has a density that is greater than the fluid it is placed in. Now, I'm going to go ahead and tell you that there are some fluids that have a very high density. For example, mercury. Mercury has a density around 13, I think. And so if you put the piece of wood in there, it would float. And just a fun fact, if you were to jump in some mercury, you would only float to somewhere, you would float or sink to somewhere in your thighs, because that's how dense the liquid is. Okay. So this says, discuss with your table partner which blocks in each setup below has a higher density. Obviously, you don't have any table partners right now. So go ahead and do this one on your own, pause it, and I want you to think about the equation for density. So remember, density is mass over volume. So I want you to think about that and determine which block has a greater density. So go ahead and pause the video. Go through it and think about it, and then when you're ready, press play. So let's go ahead and think about this. In situation A, we know that the blue block, it clearly has a smaller volume. And it also has a larger mass, which makes it to where the density of this is going to be a larger density, because when you take a larger numerator and divide it by a smaller denominator, you end up with a larger number. And so in this situation, this right here has the larger density. So let's go ahead and take a look at this next situation here. And if you take a look at their volumes are actually the same. They appear to be the same anyways. But the mass in this one is greater, and the mass in this one is smaller. And because of that, this is going to have a greater density. So we can determine that the one on the right has a greater density. Now this next one is a little bit more challenging to kind of see. So in this situation, we can see that the one on the right has a smaller volume, the one on the left has a larger volume. The one on the right has a smaller mass as well, and this one has a larger mass. So how do they compare to each other? Well, what I'm going to tell you is that if you think about it, they actually could be the same density. They could actually have the same density. And if you look, when you make a larger numerator will give you a larger number. But a larger denominator will give you a smaller number. And so if you think about it like that, it actually balances out where the increase in the numerator might be balanced out by the decrease in the larger denominator. And so these actually could have the same density. And the reality is that we actually don't know. We don't know, we don't have enough information. So the answer for this is not enough information. Let's go ahead and take a look at number 5. Number 5 says when a piece of metal that has a mass, okay, so we've got our mass right here, and I'm going to change colors just because I'm kind of getting done with that color, is dropped into a graduated cylinder, and the graduated cylinder has 23.55 milliliters of water. That's the water that it's starting with. And then the water level rises to 28.84 milliliters. So it starts with 23.55, and then the water level increases to 28.84 when the piece of metal is dropped into it. And so we're supposed to determine the density of that metal. And again, density is mass over volume. Now we have the mass, but we actually don't have the volume. It doesn't give us the volume of the metal. What it does is it gives us the volume of the water, which this right here is the volume of the water. And then it gives us the volume of the metal in the water. So again, this is the water. This is the metal in the water. So how might we figure out the volume of just the metal? Well, we can take the volume of the metal and the water and subtract the volume of the water. And when you do that, we end up with 5.29. Now, when subtracting and when adding, we need to always consider significant figures. The rules for this is not the number of significant figures will tell you how many significant figures you end with. And what I mean by that is this first number has 4 sig figs, this second one has 4. That does not mean the final answer has 4, because that's not the rule for adding and subtracting. But rather, the rule for adding and subtracting is to determine the place value. This one goes all the way out to the hundredths place. This one goes out to the hundredths place as well, so that means the answer should go to the hundredths place. And to kind of give you an example, another example of what that would be, pretend like this 4 is not here. If that 4 wasn't there, that means that this number only goes to the tens place. Because that number only goes to the tens place, that means that we can only record our answer to the tens place. But that's not the situation that we have right now. This goes to the hundredths, this goes to the hundredths, so this should go to the hundredths as well. So this number is correct when in terms of significant figures. And now all we need to do is plug this into our equation here. So we have 99.43. We divide it by the 5.29. And that will give us 18.7958 and so on. However, when dividing, what we care about is the number of significant figures. This has 4 significant figures. This has 3 significant figures. So that means that the answer can only have 3 significant figures. And this 9 is going to make this 7 round up to an 8. So the answer is 18.8. And this is going to be grams per centimeters, or milliliters, grams per milliliters. All right, there we go. And smiley face, because we're happy to be here. Now let's go ahead and do this last problem here. I want you to pause the video. I want you to go through the problem, and I want you to see if you can answer the problem on your own. And then after that, you're going to end up doing the practice problems on the next page. All right, and there we go. We've got our answer right there. And we can see that this is most likely going to be a piece of copper. Now, one thing that I want to point out is, notice how it's not exactly the same density. And this could be from a couple different reasons, but I'm going to give you some reasons that it might be from. And I think this is a good example of when at some point when we get to a lab, we're going to experience error within our lab. And so let's talk about maybe a couple errors that might have happened here. First, our measurements maybe weren't as accurate as they could have been. And that is just going to come with any sort of measurements that we make. The instruments we use aren't going to be exactly perfect. We can try as hard as we can to get them exactly perfect, but there's going to be some amount of error involved. The second thing is maybe the copper itself was not entirely pure, which we're going to talk about classification of matter in a future, in actually the next notes. But if we had a pure piece of copper, maybe there was some impurities involved in there that messed up the density of it. So those are just a couple of examples of how there's error involved in the things that we do, and how sometimes we need to, see the one that's going to make the most sense. And what makes the most sense in this situation is copper. And that's density. I hope you found this not too bad. It's pretty straightforward. If you have any questions, feel free to email me, ask me in class, anything you want, all right? Hope you have a great day. Take care.